Join me as I challenge the laws of physics and see if particles can actually pass through solid barriers. You know, when we talk about the tiny building blocks of our universe, we often think of particles behaving in a logical and predictable way. But what if I told you that there are certain particles that defy logic and can actually pass through solid barriers? Understanding how particles behave is a fundamental challenge in physics. We're talking about entities that are too small to see with the naked eye, and yet they can exhibit behaviors that seem to contradict the laws of classical physics as we know them. It's a problem that has puzzled scientists for centuries, and it's still an active area of research today. The issue is that particles at the quantum level don't follow the same rules as the macro world we experience every day. They can exist in multiple states at the same time, and their behavior is often probabilistic rather than deterministic. It's a mind-bending concept that can be difficult to wrap your head around. And when you throw in the idea that these particles can pass through solid barriers, things start to get really weird. Let's try to understand this concept a bit better. In classical physics, a solid barrier is just that, solid. It's a blockage that cannot be breached. But in the quantum world, particles don't see it that way. They can tunnel through barriers, effectively passing through them as if they weren't there. It's a phenomenon known as quantum tunneling, and it's been observed and studied extensively in laboratory experiments. The weird thing is that it's not just a theoretical concept. It's been proven to happen time and time again. One of the key experiments that demonstrates quantum tunneling is the scanning tunneling microscope. This device uses a sharp probe to feel the surface of materials at the atomic level, and it's capable of detecting the tiny currents of electrons as they tunnel through solid barriers. It's a powerful tool that has helped us to better understand the behavior of particles at the quantum level. Another important concept is the idea of wave-particle duality. In quantum mechanics, particles can exhibit both wave-like and particle-like behavior, depending on how they're observed. And when it comes to quantum tunneling, the wave-like behavior is what allows particles to pass through solid barriers. A major experiment that showcases quantum tunneling is the famous double-slit experiment. In this experiment, scientists fired a beam of particles through two parallel slits, creating an interference pattern on a screen behind the slits. The surprising thing is that the pattern shows that the particles are behaving like waves, even though they're being fired one at a time. It's a powerful demonstration of quantum tunneling in action. Another important discovery is the concept of quantum fluctuations, which allows particles to tunnel through barriers, even when they don't have enough energy to classically overcome them. One of the most significant implications of quantum tunneling is its potential to revolutionize industries such as energy and materials science. If we can harness the power of quantum tunneling, we could create more efficient solar cells, better batteries, and even new materials with unique properties. It's a future that's full of exciting possibilities, and it's all thanks to the strange behavior of particles at the quantum level. In conclusion, particles that defy logic and pass through solid barriers are a fascinating area of study in quantum mechanics. It's a mysterious and counterintuitive phenomenon that challenges our understanding of the physical world. But by exploring and understanding these behaviors, we may uncover new possibilities that could change the world. Thanks for watching, and don't forget to share your thoughts on quantum mechanics in the comments below. If you're interested in learning more about related phenomena, be sure to check out my video on quantum entanglement.